Hello there everyone, you've tuned in UXW Bill, and during the course of this video we're going to take what will hopefully be a quick look at repairing an automatic dehumidifier. This particular sorry looking thing was in a previous life an Edison 25 pint automatic dehumidifier. My grandparents bought it new in the early to mid 1990s or somewhere thereabouts. And at that point, although it makes no particular difference to us, the Edison brand was a part of a company known as Martin Industries. I don't know if Martin Industries was later bought out or if they simply divested their appliance business, but in its later years, the Edison brand was a part of the Canadian company W.C. Wood. They unfortunately folded in 2009. So we can't count on them for much of any support with regard to this particular unit, but that's okay, because the parts for these older dehumidifiers are very common and easy to find on the aftermarket today. This particular unit worked well until it got wet. It got very wet. It was probably running at the time. It went under in a basement flood, and if we look at the humidistat, we can see the beginning of the extent of the damage in the form of some very heavily corroded terminals. Now, while this is not intended as a how-to video or a guide to diagnosing every possible problem with a household dehumidifier, there are a lot of people who have told me over the years that they'd like to see me go through a repair on video and figure out what's going on with the device without doing much in the way of editing. So maybe this will be helpful to some of you out there who think, hey, I'd like to repair some of my own appliances and save a bundle in the process. Make sure that even if I decide not to repair my own appliances, that I'm not going to be taken advantage of by some unscrupulous repairman. And that's what we're going to try to do with this particular video today. As best I remember it, this unit didn't do anything when it was plugged in. And usually the case with some device that doesn't do anything when you plug it in, there's a very simple root cause. It's perfectly normal to want to overcomplicate a problem when you're troubleshooting, to think, oh, my problem's got to be different, it's got to be something that's convoluted, expensive, maybe even both. But a lot of times that certainly isn't true. So let's get started with this particular unit and just see what we might be dealing with. Now, the first and foremost thing when working on any appliance is the matter of your safety. And in this case, we need to be very, very certain that electrical power has been disconnected from the unit and that it can't be accidentally reconnected by anybody. Now, I'm out here all by my lonesome right now. My mother's off gardening somewhere, and Furhead's nowhere around, so I don't have to worry about anybody plugging this in. But if you're working with a permanently installed appliance like a central air conditioner or something where the power is remotely controlled, such as a built-in dishwasher, maybe even a garbage disposer, lock out the fuse or the circuit breaker that protects it. Make sure nobody can possibly turn it back on while you're working, because that could invite a catastrophe. So let's go ahead, take a look at the first thing in this unit circuit. There are two primary switches in most dehumidifiers. Some of them have a third that we'll get to in just a bit, but the two primary switches are the humidistat, which serves to turn the unit on and off when the desired set point for humidity level has been reached, if the unit has sufficient capacity to bring the humidity in a given level down to the target established by the humidistat. The other switch that's in most units, if it still works, is an overflow switch. And in order to see that, I might go ahead. I've got a lot of the fasteners out of this unit because it's been taken apart for a very, very long time. That is the bucket full switch. This switch turns the unit off, hopefully if it still works, when the bucket has filled up, thus preventing any floods. These can fail, and I've seen most of them fail in the closed state. That is to say, they would not shut the dehumidifier off for love, money, or a bucket full of water, and the result can be a flood in an area where you'd very much like not to have a flood. Here's a little schematic on the unit. Sometimes you can find something similar in any device that you might be working on, but don't count on it, and certainly don't count on it being readable after all of these years. We're pretty fortunate in this case. But the schematic also brings to our attention another switch that not all dehumidifiers have, but this particular model does, and that is the defrost control. If you attempt to operate a dehumidifier or any sort of refrigeration device in an environment that's too cold for it, it'll ice up. And a lot of older dehumidifiers, you just had to know when the room temperature was too cold for them to operate satisfactorily and make sure to turn them off. On these newer units, probably starting sometime in the late 80s, early 1990s, somewhere in there, they started to add a temperature-sensitive switch that would turn the unit off if frosting was detected on the coils. Now, I don't know where that particular switch is in this unit, but we may come across it later in our quest to diagnose this thing. Another interesting thing you'll notice about this unit's construction, and this is something I've only previously seen on room air conditioners, has to do with the design of the condenser coil. If you look very carefully at it, you'll see that it's made of individual metal whiskers that have been attached to the refrigeration lines. Now these things look like they're all bent over and contorted and messed up, but believe me, you don't need to straighten them, even if they look like they are a ridiculous mess. You can try, but it'll be a fool's errand. So the first thing I want to do is I want to go ahead and turn my multimeter on. Again, making very sure that power is disconnected, and if your device has a capacitor inside it, that it has been safely discharged and its terminal shorted so that it can't charge up. We don't have to worry about that here. Nothing in here is capacitor start or capacitor run. So we'll just go ahead and make our tests. Again, make sure that power is disconnected. We'll start, if I can do this. This is one of the drawbacks of having big hands. We'll start by putting one test lead on the humidistat, and then the other test lead, wherever it got to, goes on to the other lead going to the humidistat. Again, very, very, very important to make sure you're unplugged, otherwise you might blow your multimeter sky high and give yourself an awful surprise. Now we want this thing to go ahead and make a sound when the contact is established, if there is contact established. So I've gone ahead and requested that mode. Let's go ahead and turn this on and see what we get. Well, the good news is our humidistat, despite its sorry-looking terminals that might overheat later in operation and certainly should be replaced, they do appear to be good nevertheless. Now, a more difficult switch to get at is the bucket full switch. One of the contacts is relatively visible, but I may or may not be able to squeeze my big old hand back there. And unfortunately, when this thing was originally designed, they pop riveted the bracket holding the humidistat in place. I could remove that. I could go and get my tools, but I'm kind of a lazy butt, so let me see if I can pull it off by just reaching around the compressor and hooking up to the switch. I might be able to pull that off. We'll see. While I'm making this video, I probably ought to mention that it's never a good idea to try and be lazy while you're doing any kind of repair work. Yes, I finally had to go ahead and get a nut driver, 1/4 inch. Very common size when working on this sort of thing, so I could get the cover off of the unit and get at the overflow switch, which once again is just horribly corroded. To repair this unit at all properly, it definitely should be replaced, because even if it works, that corrosion inside this thing is going to lead to horrible heat buildup and might cause an electrical fire. But for the sake of a test, we can probably count on it to work well enough. I've gone ahead and attached one clip lead from the meter to this terminal on the switch, and because this other terminal is heavily insulated and didn't want to come off of there easily, probably due to the aforementioned corrosion issues, I went ahead and I followed the wire around, figured out where it went. Goes right to the humidistat, as you would expect. The two switches are basically in series with one another. And if I go ahead and release the bucket full switch to indicate that the bucket is no longer full or that it's been removed, thus allowing the dehumidifier to piddle all over the floor, we get a beep. So we know at least that switch should be serviceable. It seems like almost everything in this unit, switch-wise, passes a test. Now, one thing I haven't been able to find in this unit, despite having looked for it, is the thermal cutout switch. I don't know where they would have hidden it. Maybe the schematic lies to us. Maybe that feature was optional. Not every unit got one. I did find what might be a date code on this particular unit. I'm not really sure. OC89. Certainly could have been that long ago. Oil every 6 months with SAE20. How many people do you think did that? Not too many, but in a testament to the quality with which things used to be built before everything went to being made in China by factories with absolutely no concept of quality control. The bearings in that fan motor are still pretty good to this day. So we've checked out all the switches. All the switches seem to work. Let's go ahead and put our meter, making sure again that the switches are actually turned on and that nothing like this neon bulb that's floating around loose in here for some reason. I've never seen one like that before in a dehumidifier. Usually they're an encapsulated assembly, but this one has a very homegrown look to it. Probably replace that with something from Radio Shack if I get this unit to work. The front panel's in the keykeeper's basement. Well, let's go ahead and take this thing out of tone mode, back to continuity test. You could leave it on tone mode if you wanted to, but the tone on this particular multimeter is very shrill. We'll go ahead and put it across the terminals of the plug. And I'm guessing that the humidistat is turned off right now because we have no continuity. So let's turn it on and see what we get. Well, the circuit appears to have conductivity. So one thing we could do is a quick and dirty test. This is not really the proper way to do this. Would be to check for something like a short to ground. See if we've got anything there. I've left one clip lead on the plug and I've put another on the unit's chassis, and I should see an open loop reading or a very, very high resistance. I'll go ahead and do the other prong of the plug here. And then just to verify that I actually have got a good connection to chassis ground, because that is a possibility given the corrosion on this unit. Maybe I don't have as good a connection as I think I do. We'll go ahead and hook up to the ground pin on the plug, and we should get 0 ohms resistance or a figure very close to. So we can figure that this unit probably doesn't have a short to ground, and that while the switches are corroded and they're ugly, they should at least work for a quick smoke test. And since you all love that so much, that's exactly what we're going to do. We're going to have a smoke test. If you're going to do something similar, make sure that you're plugging into an outlet that's protected by an appropriately sized circuit breaker or fuse. You could even use an outlet strip like this with a built-in circuit breaker. But it's been my experience, especially with these cheap China Pride outlet strips, that very often their circuit breaker doesn't notice anything until it's just about time to start a fire. And usually the circuit breakers inside these things, because they take so long to trip, could take several minutes at least under a nominal overload condition, they sometimes don't survive the experience very well. Let's go ahead and plug this thing in, and we'll turn power on to the humidistat, which it already should be. The bucket full switch should be closed right now because the bucket's not attached to this thing. And we'll go ahead and turn it on and just see what we get. And right away, we get a compressor, but we have no sign of life whatsoever from our blower fan. That's definitely not what I remembered this unit having a problem with. But we'll have to go ahead and troubleshoot the fan motor and see if the motor itself is actually bad, or if there's an issue with the contacts, maybe some sort of a protection limiting device like a circuit breaker. Although most of these units do not implement a circuit breaker just for the fan motor, the only meaningful protection they have is overload protection for the compressor. But in order to check this out, we'll have to figure out where our fan wiring goes. Looks like it comes out of the motor down here, goes through this clip, heads down to the compressor, and goes inside this contact box, which is held on by a stiff metal spring band. The way to remove one of these is with a bladed screwdriver, and that's usually a two-hand job if you don't want the thing plinging off into outer space somewhere. Once again, Bill realizes that it never pays to be lazy while he is repairing home appliances. That's right, folks, I had to go and get the rest of my tools. I tried robbing Furhead's toolbox first, but he's gotten wise to my tricks and he's hidden all the stuff that he knows I like to take and return in a somewhat lackadaisical manner. So we'll go ahead, we'll pop this little guy off of here, this contact cover over the compressor. You can do this with a bladed screwdriver if you don't have sophisticated tools. I'm going to use these long nose pinchers here. Pop this guy back. That greatly reduces the chance of it flying off into outer space somewhere. Again, your power should very definitely be disconnected and locked out while you're doing this. I know I sound like a stuck record. I'll probably get caned about that in the comments. But it's far, far better safe than sorry. It's Speaking of sorry, this thing definitely looks a little sorry. Looks like we've got some pretty dodgy, rusty connections here too. A person could probably clean this up and return it to service. This is actually the compressor start device and thermal protector down here, this round thing. You can do multimeter checks on these if you had any question about whether or not they were functioning. Now, a multimeter is a very useful thing to have when you're repairing appliances, and it doesn't need to be an expensive one. But if you're suspicious of a switch problem or something simple like that, and you don't have a multimeter, you can get yourself or make yourself a sufficiently heavy collection of jumper leads that you can use to connect across switches. If I had found, for example, that this humidistat were bad and I wanted to power the unit up, I would have taken a clip lead and placed it right across these two terminals right here. One has to be very careful to make sure that they don't inadvertently clip something across a hot and neutral, or a hot to ground, or a neutral to ground, although that's less likely to be catastrophic. Shouldn't be catastrophic in a properly designed electrical system, but it's something you don't want to do anyway. So we have fan motor wiring here. We have one of these that is attached with a wire nut to the white wire coming in from the power cord. There's a brown wire that's going off to the compressor. And then we have another connection up here that is again shared with wire going up to the humidistat for switching purposes. So what we need to do, and this may be a little difficult since these are so corroded on here, not to mention these may be the irritating type that have a little nub that sticks up to try and lock these terminals into place. But we're going to disconnect the fan motor from the rest of this circuitry so that we can perform an ohmmeter test on it and find out whether or not its resistance is within specification or at least plausible, or if the motor on this unit is lunched and needs to be replaced with another one. So give me just a moment to go ahead and lever this off of here, hopefully without breaking anything in the process, although that is pretty rusty. This may take a little bit of fiddling. Oh, there we go, I got it. But it's sistered with this other terminal coming off of the humidistat. Well, that shouldn't be a huge problem. A bigger problem is this thing. This is a pinched on wire nut. These are commonly seen because I guess they're cheap, pretty vibration resistant, but they do complicate testing things somewhat. So I'll have to uncrimp this, and then I can make a multimeter check of the resistance across the blower motor. Between the previous scene in this video and this current scene, it dawned on me that I probably wouldn't have to take this wire nut apart, especially since I can isolate the hot line going to the fan motor. In order to make a test, I should be able, although this may not be universally true for every appliance, to attach one clip lead to the neutral side of the plug, which in turn would be connected to the neutral side of the motor, and then to attach the other clip lead to the hot side of the motor and see what, if anything, we've got. And I didn't hear a tone, and I'm getting an open loop indication on my meter, although not every meter will continue to read accurately when it's in the tone mode. This one seems to, but it looks like we have a bad fan motor, ladies and gentlemen. So we'll have to see about replacing that. We could do another test very quickly. We could hook this up and apply power. Change this thing back to its voltage measurement mode and get on the neutral connection here. We could apply power to this thing and just see if the little fan motor is getting 120 volts AC. These test leads are probably a little thin for that, but I should be able to get away with it passably well. Alright, we're getting proper line voltage. The fan motor just doesn't do a solitary thing. So I think we can say with a great deal of certainty that the fan motor is dead and we need a replacement. Luckily, I've got one. This particular sorry dehumidifier sitting over here suffered a failure of its refrigeration system. I found it cast out in someone's trash collection, but the trash collection isn't going to pick up something like this. And these sealed systems, you can recharge them and troubleshoot the leaks in them, but I've been told that it's not really worthwhile by several professional appliance repairmen. But what we do have here is a good fan motor, and it will happily fit into that unit over there. At least that's my brilliant theory. The manufacturers do sometimes have different mounting schemes. I may be skinned here. Yeah, it looks like I might be. This motor doesn't have the same mounting setup that the other one does. Since I've made the most unfortunate discovery that I do not in fact have a suitable replacement fan motor for this unit, we'll just have to go ahead and remove this motor and see if I can source a replacement from somewhere. I do have a couple of other refrigerationally challenged units kicking around, but I don't think they use suitable motors either. While I was fiddling around with all of this, I did discover where the thermal cutout switch on this thing is. It's in an unusual place. I'm actually used to seeing it mounted to the evaporator coil so it can really detect the drop in temperature. But in this case, it's actually on this particular refrigeration line, swaddled under a bunch of refrigeration. These tan wires escaped my attention because I almost thought they looked like some kind of capillary or refrigerant tubing at first, although obviously they couldn't be if I'd have stopped to think about it. So the only thing I can do now, because unfortunately this motor will not come out of here by simply removing the two bolts and trying to release the tension band, the clip that holds it to the fan, that holds the fan to the motor shaft, I'll have to go ahead and remove this framework. And in order to do that, I'll bend back these little clips that hold all these wires in place, and I'll carefully, at least I'll attempt to do it carefully, deroute them from their locations. Now if you find yourself doing this in your own appliance repairs, and you think you might have trouble getting it back together, or it might be a while before you can get it back together, you'll want to take detailed photographs. Digital cameras, cell phone cameras, doesn't need to be a high-resolution camera. As long as you can see the way in which things went, you'll be good to go. Because what's obvious while you're taking this thing apart may not be obvious a day or two later when you're trying to put it back together again after getting the parts that you need. This is a woefully inappropriate screwdriver to be using for this purpose. Probably ought to see if I can find a shorter one in here. Ideally I would have my nut drivers out here, but once again I'm trying to be lazy, and this time I think I'm going to get away with it. Now I do want to be careful around this capillary tubing, because if I bend or kink that, boy, that one's stuck. I may have to get a nut driver for that one. I will be in a world of hurt, so you don't want to get too rambunctious with any of the refrigerant tubing. I'm going to work on this a little bit, see if I can get it to come free, because I only have a couple nut drivers out here with me, and I got lucky in that one of them's the right size. Well, I didn't get lucky, I went and got this one. That this one was the right size for the cabinet, and this one was the right size for the screws on the motor, but it's not the right size for these that hold the motor bracket in place on the sides of the refrigeration coil. So I'll be right back after I've gotten that undone and I get this bracket out of the way. That's certainly interesting. The fan came off as a complete unit, including the cardboard shroud. I'm really very surprised to see that. I'm a little less pleasantly surprised to see this thing. This sort of locking washer style device on the end of the motor shaft. I guess they wanted to be sure this wasn't going to come off of here. Unfortunately, I don't know of a good way to remove these without absolutely mauling them. But sometimes if you carefully lever them up with a bladed screwdriver, as I'm doing right now, you can get them to come off without absolutely ruining them. I really think these are a one-time use part, and that if you end up taking them off, you're supposed to replace them. They're a pain in the butt. That's the professional language I'll use for it, as opposed to the more vivid language that I might use to describe this. But I'll just keep gently levering this thing up until I get it to come off the end of the motor shaft. And then it'll be time to go ahead and take this spring clip, come on, focus, which can be easily pushed together with some kind of a pliers, if I'd quit dropping them while on video. But you can easily push this together and that will cause that band to slacken. And you might think you're going to get the fan blade off then, but 20 years of dirt and grime and dust and corrosion will probably greatly complicate your existence. Despite my great propensity to do everything in the most difficult way imaginable, I hit upon a much better idea to get this little friction fastener off of the end of the motor shaft. Rather than trying to lever it off there with judicious use of a screwdriver and some rather unprofessional language, since I am of course shooting this video outdoors, I decided to switch over to one of my little hook style devices and carefully bend one of the tabs out of the way. Again, I don't really think you're supposed to reuse these, but with care it can definitely be done. Now that I've managed to do that, it's time to go ahead and get the fan blade off of here. I better use a slightly beefier set of needle noses than that. We'll start by taking this ring off. They actually make a special set of pliers for these called snap ring pliers. I have a set somewhere. Well, my dad has a set, but just like Furhead's tools, I'm not past shamelessly borrowing it. But as you just saw, judicious and careful use of a needle nose pliers can remove them as well. And then, at least in theory, this fan blade would come off. But as I told you earlier, years of corrosion, the fact that this is not a loose fit, and probably some other factors as well, such as the thermal cycling around the motor and the fan environment, have all conspired to ensure that this fits on here very tightly. Now, because this is a plastic fan, we can't be too rambunctious with it. I don't want to grab it by any of these paddles and try pulling on it, because that will throw it out of balance, same as it would a metal fan. It could also result in these fan blades striking some part of the unit, which probably won't break it, but it will fray your nerves like you would not believe. So you don't want to do that. When you remove this, you want to apply even, gentle pulling pressure to the center portion of the fan's blower shaft. So you want to make sure that you're applying even and gentle pressure to that. You can use a screwdriver, but you do have to be careful not to break anything in the process. Most of the time, a little bit of handwork and some elbow grease will get this thing to pop right off of there in relatively short order. So I'm going to pause the camera and lift this blower right off of the motor shaft. Now, with the blower blades having been removed, liberating the motor is a simple matter of loosening the two nuts that fasten on to the motor's mounting studs. Again, it would be a lot easier to do this with more than one hand at my disposal. Okay, there we go. Got it loosened up enough there that I can take it off by hand. And then I'll just go ahead and do the other one here. And with my needing to remove the motor completely from this unit to search out a replacement, I could try to pinch this wire nut opposite the direction it was crimped, but more often than not, it's just as easy to simply clip all the wires going to it and throw it in the trash. You're really not supposed to reuse these. There is certainly a risk that if you tried, because the metal has already been crushed and deformed during the crimping process, that it could just fold in upon itself and poor electrical contact, possibly leading to a fire, would be the result. We don't want any fires. Now, something that I noticed about this motor when I got it out of the unit, it seems that unlike a lot of them, it's not spot welded or pop riveted together. It looks like I could actually take this apart. Now, ordinarily when one of these little motors stops working, it's an irreparable part. But sometimes you can get lucky and you can manage to fix one, especially if it overheated due to lack of lubrication, stiff bearings, or any similar cause. You could even, in theory, take this to an electric motor shop and have it rewound, but for these little motors, it's oftentimes not worth putting anything into them. But sometimes when the thermal protector pops or something along those lines happens, it sacrifices itself in the name of protecting the motor. Since this motor is not permanently assembled, it's just got these little clips that hold it together here at one end, I could take it apart and see if I can find anything that might be obviously wrong inside. The odds are pretty slim. If it's the thermal protector that's gone bad, I could bypass it or get another one somewhere. That would be the safest thing to do, obviously. I shouldn't suggest that you bypass anything other than for testing purposes, because again, you don't want to have a fire in your house. But if it's somewhere inside the windings of this motor, which it might very well be, if they've broken or corroded in two, it's probably not worth having it professionally repaired or attempting to find and fix the defect myself. But I'll go ahead and pop the cover off of this motor. It's a simple thing to do. I've done it before. We have an inducer blower on our furnace that went under in two of the Great Basement Floods. No, one of the Great Basement Floods. And I actually took the motor apart. It too was a Fasco motor, very much like this one, just more ventilated. And I popped it off, excuse me, and drove new bearings into it. That was all that was wrong with that little motor. The bearings had gotten so stiff that it would overheat if it tried to run for any length of time. So I just took it apart. I used a punch to drive the bearings out of both ends. I got some replacement bearings at an electric motor shop, and then I clipped the little motor back together. That's been at least 12 years ago, and that little inducer motor is still running beautifully to this day. In case you might be wondering how to do this, or if there are any pitfalls to watch out for, when your motor casing is held together with little clips like this, it's actually pretty straightforward and easy. The only pitfall to watch out for is that these are under considerable spring pressure, and they are yet another part that can go flying off into outer space if you're not careful and you let them get away from you. As such, you might want to wear eye protection while you're doing this. There might be a tool that's more appropriate to actually removing these things, but I have always used a screwdriver. Why a screwdriver? Well, because every other tool that you have is a hammer except the screwdriver because it's a chisel. No, not really, and anyone who treats their tools like that should be ashamed. You shouldn't do this with a screwdriver. They're not intended for prying, but everybody does it. So go ahead and just lever this little guy up, and you'll probably see it spring off of there just like that with alacrity. Luckily it landed somewhere in my truck bed. You can cup your hands around these. They don't come off with enough force that they'd cut you unless you're very thin-skinned. You don't want to gouge into the insides of the motor because you might damage the fragile varnished magnet wire, or you might even drop your screwdriver on the ground, which is also not recommended. Just carefully lever these little guys up. They go pling, and then in theory at least the motor should come apart. But it's probably not going to come apart very easily because, again, time, corrosion, thermal cycling, debris from previous lubrications if you actually did what they told you to on the motor's label. We can gently pry this apart, maybe wrap it with a mallet, a rubber mallet, and we'll see if we can get it to actually come apart. You will, of course, have to establish a beachhead from which to mount your invasion on the motor's inner sanctum. For motors like this one that actually have lubrication holes that, once again, nobody ever uses, you can oftentimes take a thin-bladed screwdriver and carefully lever the motor apart at that point. And then you might, if you get really, really lucky, be able to simply slide the end off of the motor shaft, take the armature out. Boy, does that look pretty rusty. I don't know, I think this motor is probably a write-off, but I was going to at least take a quick look and see. There you can see the windings, the armature of the motor, how filthy that back bearing is. Wow. Yeah, I think this poor little motor might be a write-off. That's probably the thermal protector right down there, that little bulb-looking thing. I don't know if I can actually get that out of there. It's possible that that is actually riveted into the motor somewhere. Probably not very easy to remove. Off the top of my head, I certainly don't have any idea how to do it. And this was really an exercise that was just for fun anyway. I didn't take this motor apart with having any serious intention of repairing it. I can't imagine these are terribly expensive to find, but I may get a surprise when I go looking for them. It's been over 20 years since I had to buy one of these for that Cold Spot 30 dehumidifier that I've still got. It still works flawlessly and has shown up in a previous video if you want to see it. Judging by the amount of crud in here, I'm thinking that maybe someone actually did take this motor, did take the dehumidifier apart and periodically oil the motor like they were supposed to. Just amazing. And finally, if by some chance you do decide that you can repair your little motor, or it's less stricken than this one happens to be, or you're better equipped to actually work on it than I am, these little clips are not hard to put back in place, even though they come off of here under considerable spring pressure and with a great deal of alacrity. All you have to do to get them back into place is usually push them in with your fingers. It looked like I could do this when I was getting ready to set up this scene, but now it seems that I can't. Of course, it would make a fool of me while I was on camera. Oh, very close. I almost had it then. But if by some chance you can't get it that way, you could always gently click it into place with a pair of needle nose pliers. Again, maybe slightly heavier duty than these. Ah well, you get the idea. It's not easy doing all of this stuff while I'm holding the camcorder. There we go. I managed to get that one in place by hand. I never did find the fourth one. I think it's actually under the dehumidifier. But in the meantime, folks, until such a time as I can source a new motor for this particular unit, I'd like to thank all of you for watching. Before I go ahead and shut the video off, I'll give you one more bit of guidance that you might find useful along the way. If you know that it's going to be a while before you get a particular unit put back together again, one thing you can do to save yourself a lot of grief is to replace as many fasteners as you can in the places from where they came originally, such as this humidistat. You don't have to put the screws in all the way, just so long as they're tight and they won't fall out. It's also not a bad idea when you're putting these screws back in to get yourself just a tiny little drop of motor oil and put on the end, because very often you'll find that you're going into dry metal. Sometimes they go in smoothly like this one is. Sometimes they don't go in nearly so smoothly in other cases. But I'd like to thank you for watching. And while again this really was not intended as a how-to video, it does show you some of the diagnosis procedures that you can use to determine what's wrong with similar appliances of your own, even if they're not dehumidifiers. Because the good thing about appliances is that so many of them, the overwhelming majority of them, are just variations on a common theme. They turn, they have switches in them, thermostats, they all operate on a very similar set of basic principles, and once you have those down, you'll be surprised, even in this day and age of electronically controlled appliances with microcontrollers and stuff like that inside them, just how many things you can repair, or at least have some idea as to a diagnosis, so that you'll be more informed when you decide to call a repair shop, if you decide to call a repair shop. So again, thank you for watching, and by all means do feel free to leave a comment if you happen to have one. And yes indeed, folks, I did manage to find the last little clip that holds this motor together.